All right, so in this section, what we are going to learn is 4 pretty hefty concepts that are going to follow us about for the rest of the semester. So one of them is interval notation. Another one is what is a function and what is function notation. Then we're going to look at domain and range, and then we're going to look at whether a function is increasing, decreasing, or constant, or all of the above, or none of the above, or some combination of the above. So interval notation, first of all, let's look at that. What we've always taught you up until now is inequalities. So for instance, I've said x is less than 3. So if x is less than 3, how many solutions are there? So your better question is, how many numbers are there that are less than 3? And there's an infinite number of them. So this is a really compact way of saying that this value, the x value that works, as long as it's less than 3, it works. So you've got an answer there. Now, when you learned inequality notation, your brain was not advanced enough to do interval notation. So what we're going to do is we are going to look at a number line, and we're going to use a number line to convert between inequalities and interval notation. And then like when you get up into pre-cal and stuff, we would just dive on over into interval notation instead of using this little conversion. So what number am I interested in? I'm interested in 3. And then all of my x's are less than that. So I'm going to shade all of the x's to the left of 3. And all that is saying this point and this point and this point and this point, all of these work. Well, math people are lazy, which means we are actually just going to shade it in and say, look, all that stuff works. Now, are you allowed to use the 3? In other words, is 3 less than 3? No, it's not. So I cannot use the 3. So I'm going to put the 3 under a microscope, and I'm going to look at the point that's at 3 and zoom in on it, and it's going to be an open point. So in other words, 2.9 works. 2.99 works. 2.999 works. 2.99999 with an infinite number of 9s works, but 3 doesn't. Okay? So that is how we graph this thing. So notice that if I've got a less than or a greater than, I would normally use an open circle. When we translate this into interval notation, we're going to use parentheses, which I'm going to call soft brackets. Okay? And so this is, in inequalities, I would use a less than or a greater than, and then an open circle on my graph. Well, with interval notation, we're going to use soft brackets. So here's the question. How do we read? We read from left to right. So where does my answer start? My answer starts somewhere over here in negative infinity. So I'm going to use negative infinity. And then the next thing I'm going to write is, where does my answer stop? Well, my answer stops when I get infinitely close to 3, but I don't touch the 3. So this soft bracket says get close, but don't touch. Okay, get close, but don't touch. Because infinity is a concept, whether it's negative or positive, you cannot equal infinity. Therefore, the infinities, positive and negative, will always get soft brackets. Always. So this is inequality notation, and this is interval notation. Okay, so from negative infinity, soft bracket, all the way up to 3, don't touch, that's all of the x's that work. So from left to right, you're going to tell me, or from bottom to top, okay? So either left to right, because left is where the negatives are, or if you're going up, down, down is where the negatives are. So you're either going to start at the left and go right, or you're going to start down and go up. Now let's try another one. What happens if I say something like x is greater than or equal to 7? Okay, so let's practice this one. I have a number line, and I'm interested in 7. You cannot see. I'm interested in all the numbers that are bigger than 7. So all of these are bigger than 7. But can I use the 7? This says greater than or equal to. Okay, so greater than or the same as. So yeah, 7 works. So I'm going to use a filled in circle for 7. So notice up here I had an open circle, down here I have a closed circle. So now I'm going to introduce a new thing. If it is equal to, I'm going to use hard brackets. And that's when I have the or equal to's. And in inequality notation, you would use a filled in circle. So notice you've got little horizontal bars here That's for equals. You also have horizontal bars here, which is for equals, okay? So, reading from left to right, where does my answer start? Bam! Starts at 7. Can I touch the 7? Yes, I can, okay? And then where does my answer end? It's going to go forever and ever and ever off to the right to positive infinity, and positive infinity always gets a soft bracket. Okay, so what happens if I have something in between? So let's do let's do 0 is less than x is less than or equal to, I don't care, 4. Okay, so if I were to draw this, and remember our number line is just going to give us something to visualize what's happening. X, all right, so 0 is smaller than x, but x is smaller than 4. So x must be between 0 and 4. So here's 0, here's 4. X is between them. 0 would get an open circle, and 4 would get a closed circle because it can equal 4. And so now read it from left to right. Where does your answer start? My answer starts at 0, but does not touch. Where does my answer end? It ends at 4 and does touch. Okay. Last example is what happens if we have a gap. Okay, so I'm going to come back up here because I did poor planning. And so this one is x is less than 3. All right, so let's say x is less than 3 and x is greater than or equal to 4. Okay, so I'm going to modify this problem. So what I have is a number line. I'm interested in two numbers, 3 and 4. X can be smaller than 3, but it can be bigger than 4. 3 would have an open circle, 4 would have a closed circle. So now we're going to pick this thing back up. Where does my answer start? My answer starts in negative infinity. It comes screaming up to 3, but he does not touch the 3, so it's a soft bracket. And then I've got this gap. Okay, so hop on over. Where does it pick back up? It picks back up at 4, and it can equal 4, so you have a hard bracket, and then it's going to shoot off to positive infinity. So this is a really intense way of, sorry, I have a sunbeam. Okay, this is a really intense way of writing this answer and this answer. Well, the mathematical symbol for and is a union symbol. It looks like a U, but it means and. Okay, so it's all this stuff, and I wonder what would happen if I turn this on. That does not work at all. Okay, so I was trying to turn the lamp on. So that is interval notation. So now let's talk about functions. So if I have a function, I want to decide if something is or is not a function. And the way I can do that is a couple of different ways. If something is a function, it simply means that I have made a test to it. I've done a test to it. And if it passes the test, I can say it's a function. So everything in math, if it has an equal sign or an inequality, if it has an equal sign or an inequality, okay, all of those things are relations. In other words, how does the left relate to the right? If it passes a specific test, we can say, okay, you're a function then. And it just gives us a little bit more information to work with. So a function is a relation, but a relation is not necessarily a function. So it's called a subset. So think about a mom and dad and kids. Okay, the kids are a subset of the family. They're still part of the family, but they're not the parents. Okay, so that's what a function is. Now, if we have a picture, we're going to do what's called a vertical line test. And all that means is, does any vertical line I draw hit the picture one time or not at all? So let's try a couple that work. All right, so let's say I've got a parabola, which you don't know what that is yet, but here we go. Okay, if I draw an infinite number of vertical lines, regardless of where I draw that vertical line, it's only going to hit the graph one time. Okay, so the graph is the actual parabola. It's not all the rest of the stuff. So it hits it once. So he passes. He passes the vertical line test, which means now I can relabel him as a function. So let's do one that's not. What happens if I draw a circle? Okay, so over here I'm drawing vertical lines. They don't hit, which is fine. I don't care. Okay, well now when I start drawing these, a single vertical line hits the circle multiple times. Okay, it's only got to fail once, by the way. Well, I just drew 3 different times it failed. So it actually fails an infinite number of times because I can draw an infinite number of vertical lines. And then use all of my ink. Okay, so the circle fails. He does not pass the vertical line test because a single vertical line hits the picture of the circle more than once. So he is not a function. Okay, he is a function. So if you don't have a picture, what you can ask is, do any x's repeat? Okay, so you want a single x. So let's look at this. If I have a point on here, the point 2 comma something, okay? 2 only produces a single y value. So 2 only appears once. So that says 2 comma y, and my pen just broke. Okay, so that says 2 comma, I don't even care what y is. Okay, I just randomly grabbed a 2. What happens if I grab a negative 4? A negative 4 will produce a single y value. Okay, so come over here. Well, that's what happens if, and I'm just grabbing random numbers. Okay, what happens if I shove in a 1? If I shove in a 1, I'll get a positive y, but I'll also get a negative y. So a single x value will appear more than once. A single x value can only belong to a single y, and this x value belongs to 2 different y's. So he fails. Okay. Now, what is function notation? As soon as I decide that something is a function, I'm going to change it into function notation. So function notation is going to look something like this. Instead of saying y equals 3x plus 4, I can say, okay, that's a diagonal line. Whoops. Okay, it looks like that. There's my diagonal line. Okay, and does it pass the vertical line test? Yes, it does. Okay, so if he passes the vertical line test, then what I'm looking at is he's a function. So what I'm going to do is I'm going to communicate the fact that I've done that vertical line test, and I'm going to tell you I am a function. My variables are x's. I am a function. My variables are x's. This does not say f times x. Okay, this says a function of x. Okay, so all that means is somebody has done all the work for me and has said, okay, this is a function, so now I can move on with life. So what happens if I've got another one? So let's just say on the same coordinate plane, we're going to do the square root function. Then what I would probably do is just continue on up in the alphabet and say, okay, this line is f of x, well, g of x is the square root. Okay, all that means this is not g times x. This says I am a function, but I already used f, so I'm going to move on to g. Guess what's next? I bet it's h. Okay, and the variables I'm playing with are x's. Okay, so another cheaty way to do this is, and this is not true 100% of the time, but it's true about 99.95% of the time, is look at your y's. If your y's just have an exponent of 1, it's probably a function. Okay? And for college algebra, that's a good rule. When you get up into calculus and stuff, it gets a little bit more exciting. But if you have a y and his exponent is 1, you can pretty much say it's a function. Okay, so now we have done, wait a minute, I've lost control. We have done interval notation functions, so now we're going to talk about domain and range. So what, actually, I'm just not even going to do that. Domain and range is going to be, your domain is all the x's you're allowed to use. And your range is all the y's that are produced. Okay? So your domain, so look, it's in alphabetical order. Domain comes before range, D comes before R, X comes before Y. So your domain is all the X's you're allowed to use. Okay? Your range will be all the Y's you're allowed to use. So when we get to these examples, I'm going to show you some little hints. But basically, you start looking for function types. And you try and think through about what can and cannot happen. Okay? Increasing, decreasing, and constant. We're going to look at an airport and an airplane. Okay, so if I have an airplane that's taking off, okay, that means I know, and I'm doing this from left to right. Okay, that means I know. How do you know he's taking off? Because you're watching it move and go up. You are watching that airplane go up. How do you know the airplane is coming in for a landing? How do you know the airplane is decreasing? Reading from left to right. Your airplane is going to decrease. Okay? How do you know that the airplane is constant? That means it's not going up or down. So that means he has reached his cruising altitude. Okay, so he'll just be flat. Now, what happens if I go to the airport? That's my airplane. Okay, What happens if I go to the airport and I see an airplane in the sky? Is this airplane going up or down? You don't know that because you're not watching it move. Hang on, I told you, I just interrupted myself. Let's say I go to the airport and I take a picture of an airplane, okay? Is that airplane going up or is that airplane going down? Or is that airplane moving in a flat line? Has it reached its cruising altitude? You can't tell me because it's a picture in time. You must see movement, okay? So I'm saying that to say when we use interval notation for increasing, decreasing, and constant, you will never use hard brackets. Never, never, never. Because if you use hard brackets, then you're telling me that a single point, so it would equal that point, okay? You're telling me that a single point can go up or down or flat, and it can't. It's a point. You're telling me movement, so I need to see width. So whenever you're doing increasing, decreasing, and constant, you will always use soft brackets, and you'll read it from left to right, okay? So we're going to come back in a second video, and we're going to do some examples.